My name's Nick. I'm one of the Android developers at RetailMeNot, and sometimes I pretend to be a designer. This is going to be one of those times. If you want to follow me on Twitter, just my first initial and then last name. Very simple. Don't try to pronounce it, though. You won't be able to. So this talk is going to be really simple. We're going to be talking about animation, user experience, and brains. So first, we're going to start with a little bit of natural motion and what that means. We're going to be talking about holding users' focus, and then we're talking about framing attention. Then we'll get over to material motion, title of this talk, and finally we'll finish off with some goop. So how many of you guys went to the other material design talk here? Great. So now you're all experts in material design, right? Sweet. This talk is going to be a little bit more designy with some Android implementation. So, but there's still going to be a lot of Android stuff in this talk. So for those of you who don't know what material design is, though, I'm going to explain it in 3 cards. First thing is material design is material. So views look as if they're made out of something real and natural, right? So a paper or plastic or gel. The views then respond in the way that that material would respond, right? So you don't expect a piece of plastic to fold over on itself. So why would the view, if it's made out of plastic, respond as if it would fold over on itself? And animation. Views animate in meaningful ways and guide the user through the app. So Google kind of gives us some nice little guidelines on this, right? So for material, they kind of give us this nice animation, right? So things kind of morph into one another. You can kind of sense what material the view is made out of, something by how it looks. And then you can also kind of get a feel for how that material behaves based on the interaction with it, right? So in this case, we kind of got a slip of paper, and it's getting picked up off the page and moved around, right? And it feels natural. It feels like a piece of paper should behave. And finally, we have animations. And Google tells us that animations should be meaningful and guiding. But what does that actually mean? What does meaningful and guiding actually entail for your app? Well, the first thing is it's got to respond to the user, right? If the user doesn't tap on a view, then it's not meaningful. Why did it animate, right? Why did your animation kick off before the user interacted with it? The second thing is, in order to actually be meaningful, it has to guide the user's focus. Your animation has to have a purpose, and it has to serve that purpose, and that purpose is always going to be to guide the user's focus. And finally, while you're guiding the user's focus, you're going to be creating new context for your animation. You guide them to what they're supposed to look at, and your users kind of understand what they're supposed to look at, and they get this new context based off that animation that you played for them. So let's talk a little bit about natural motion. So what is natural motion? What is unnatural motion? And why do we care, right? So natural motion keeps motion believable, right? Things animate on the screen in a realistic way, right? So in order to do that, we kind of have to calculate, right, where an object should be in the animation given the time, right? Because time flows linearly, but your animation might not. So we need to interpolate it. And that's what motion interpolation is. So given a formula, we animate our time, or rather we interpret our time into a set of values that we're then going to use to play our animation. So there's a couple of ways to interpolate motion, and I'm kind of going to go over 4 of them real quick to give you guys an idea of the basics that you guys need to know in order to make your animations natural and believable. The first is linear animation, and quite simply, linear animation just means that when time flows, your objects move linearly, right? So as our time increases, our object moves just with that time. We can also do what's called easing in. And as our animation moves forward, our animation will actually accelerate. So here's kind of an example of that. So by the time it reaches the end, it's sped up a little bit. We also have the opposite of that, which is our animation decelerates while it's moving. So it starts off really fast and kind of slows down towards the end. And finally, you can combine those two. And you can ease in and then ease out, right? So your animation starts off slowly, speeds up, and then slows back down. So watch that blue dot, sped up, and slows down. So why do we care about any of these things? So in order to keep your motion believable, you kind of have to apply these interpolations in a way that makes them believable. So the first one is easing in. And the reason that you would use an ease in animation interpolator is for objects that are leaving the space. Your object is still on the screen, then it starts speeding up, leaves the space because it's sped up and it's going off the screen. And the reason that you want to do this is because it's actually more natural. Objects speed up as they're leaving the space. Your user has the time to notice that our object is moving, but by the time it's actually left the space, it's sped up fast enough that the user knows that they shouldn't care. The user can kind of predict that that object is going to leave the space. Similar thing for easing out, or rather the opposite thing for easing out. Your objects are entering the space. So as your objects are entering the space, you want them to slow down. User will have a little bit more time to figure out where that object is going to end up. Easing both is for when your object is moving within the space, right? So if your object is going to be moving across the screen, you want to speed it up. Sorry, you want to start off slow. You want to speed it up while it's actually in motion, and then you want to put it where it ends up. And finally, we have linear. Don't use this. It's super unnatural. It's super robotic. This is what unnatural motion is. Unnatural motion is linear motion. If you want to keep your motion natural, use one of those other three, depending on what your animation needs. However, I will qualify this by saying that an object in motion stays in motion, and that part is natural. So if your object is flinging across the screen, flying through your application, or in general just coming on the screen and then leaving immediately, go ahead and make it linear. That's fine. Your object shouldn't be slowing down if it's not stopping on the screen or if it didn't start from a standing position. So how do you do this in Android? Turns out it's ridiculously simple. We have these things called time interpolators, and Google has built them all for you. You don't need to do any of this. Ease in is just an accelerate interpolator, because that's all it does. It just accelerates the object. Ease out, decelerate interpolator, and then when you want to use both, accelerate, decelerate interpolator, just how you would expect. And when you're animating the view, right? So how do we actually animate a view? Well, we grab the view from our ID. We call animate on it. We do whatever animations you want, translation X, translation Y, translation Z. You can use that for this. And you just call set interpolator. And just pass in a new animation interpolator. If you want to have these, what's it called, static in your app, that might work. But you just pass that in and hit start, and boom, that's it. Your animation plays. It's really that simple. All right. Now I want to talk to you guys a little bit about evil. I want to talk to you guys about the square root of all evil. I want to talk to you guys a little bit about premature optimization. So, what is premature optimization? Premature optimization is when you take a thing that you think is going to be slow, but you don't know it's already slow. You just think it. And then you go ahead and you make it fast without ever knowing whether or not it's actually slow. So for example, if you were to build out your app and you had a spot on your app that you were sitting there and you were like, hey, you know what really makes sense in this place? An enum. But Colt told me not to use enums, so I'm going to go ahead and make this intdef. And so now you've made this enum, now you made this intdef enum, and your code's all messy, and everywhere is ints, and you're using the annotation processor for type checking. Well, when your intern comes in, trust me, he's going to screw that up. And that's all because you did some premature optimization. Oh, and by the way, while you're all doing your enums and intdefs, your networking class is leaking memory because, or rather creating thousands of objects because you're using JSON. So how do you avoid premature optimization? Well, it's actually really simple. Fix the slowest thing first. Don't fix something you don't know is slow. Find out what's slow in your app, and then fix it. So with that, what's the slowest thing in your app? Call it out. What's the slowest thing in your app? Anybody? Your apps are all super fast? All right, great, because you're wrong. There is a slowest thing in your app. The slowest thing in your app is your user. Your CPU operates on the order of milliseconds. Your user takes 200 milliseconds between the time that they decide to click on the button and the signal from their brain goes to their finger to actually click the button. That's how slow your users are. Your user might take 2 seconds to figure out they wanted to click that button in the first place. So, how do we fix this? That guy's got the right idea, but Singularity is a little bit off. Well, it's the same way that you would fix any optimization problem in your code. Hit the fast brain code paths. What brain code paths are actually fast? So just in general, you have a couple of things in your brain that are faster than others. The first one is colors and shapes. Colors and shapes you recognize really, really fast. If you've got a bunch of colors on the screen, you can identify those colors really fast. If you've got a bunch of shapes on the screen, you can identify those shapes really, really fast. If you have a bunch of text on the screen, that's really slow. That requires a lot of processing. The other thing is actually groupings, right? So you guys, as soon as that animated on the screen, you guys saw all, 4 by 4 of those dots, 16 dots on the screen as one group. Great. That's super fast. If I split them apart, your brain kind of automatically just generates that there's 4 groups on the screen now. Super fast, always group things together. Your brain optimizes that for you. And finally, peripheral vision. Stuff that's coming out from the side of the screen or not directly in your center of vision is going to be processed twice as fast by your brain than stuff that's directly in your center field of vision, right? And you can actually find out a lot more of this. This is just scratching the surface. There's an amazing talk from Google I/O 2013 called Cognitive Science and Design, and this is exactly where I'm pulling all of this from. And there's so much on that talk. Everything, the guy goes on in that talk, I'm going to miss half the stuff that he talks about, but these are the core things that mattered at this presentation, so this is what I'm going to mention. But if you guys are interested in how your brain works, go watch that talk. It's on YouTube. It's amazing. He also talks about tigers. All right, cool. So now that we know what are the fast pathways in our brain, how can we abuse them in order to create animations that are going to be more meaningful to your user? Well, we create animations that are guiding. So we have this super awesome animation from the Google Play Store, right? That Instagram logo just pops right up to that top as soon as you click it. Why would you do that? Why would Google go through the effort to make that animation? Well, it's because that animation guides your eye right there to that point in where the arrow is, right? Well, guess what? That's right in line with the install button. And because they put that little divider line right there, your brain groups that together. Your eye already lands exactly where Google wants you to be, which is next to that install button. They could actually probably improve this further by moving the install button on the other side of the screen, and then your install button is right underneath your logo that they animated to. So that provides context to the user, right? But there's something else that we can do. And that's that motion attracts attention, right? So remember what I said about peripheral vision? Well, whenever something moves on the screen, your brain kind of snaps to it, right? In that way, your user is very similar to a T-Rex because both of their visions are based on motion. But there's an alternative to this. Don't move anything that you don't want to attract attention to, right? You don't want to attract the attention of that dinosaur in the same way that you don't want to attract that attention of that user. You don't want to attract attention to anything that you don't want people paying attention to. So don't move it, right? Don't move stuff across the screen if it's not the core focus of your application or of that screen. And then also, don't move more than one element at a time. This is really important. There should only be one thing moving on the screen at a time. So let's take this animation that we had kind of in the beginning of a talk. And this is a really complicated animation that we have, but it still follows that principle of not moving more than one thing at a time, even though there's a bunch of shit moving on the screen. So first of all, notice that those teal bubbles, they fade. They don't move. They just fade away. That one bubble moves and then expands out. But then those orange blocks, they still move one at a time. By the time one of those orange blocks finishes moving, that's when the next one starts, and they're also fading in. So even though we've got a lot of motion on the screen, we're still only moving one thing at a time, which means your user knows what to focus on because they're going to focus on the thing that's moving. That's the thing that's going to attract attention. All right. So, motion attracts attention. More motion attracts less attention. Subtle motion attracts less attention. So, if we don't want to attract something attention to the screen, but we still want to move something on the screen, how do we do it? Well, we do it subtly. So why do we actually need subtlety, right? So here we have the Google Play Store, the Google YouTube app. And whenever you swipe through this app, right, we kind of got a lot of our attention going on the sliding content right in the center of the screen. So that's all great. But then we got this thing in the top corner that keeps shifting around, right? That subscription to account. And your brain kind of notices that, right? The sudden flickering, your brain pays attention to that, and then, well, you notice it. Now, in Google's case, they might actually want you to notice that. They might want you to know which tab you're on. But maybe for your application, you don't want them to notice what tab they're on, right? You just need that title up there because some PM told you to, right? But you don't want them to actually pay attention to that. Well, you could do a lot to reduce that. The first thing that you could do is fading, right? But we'll get into that in a minute. So let's use everything that we kind of learned to build up our UI. First thing is fade unimportant elements in and out, right? When you look at this animation that's playing, notice all of the other icons on the screen. They fade out. They just fade away. They don't move. They fade away. Now, how many of you guys have seen this GIF? How many of you guys noticed that that's a different guy? Right? So your brain kind of has this bit of an optimization. When we interrupt your brain with like a full kind of bleed image and we completely erase your field of vision, your brain kind of forgets what was going on. We can use this to our advantage in a great way. So you see all those tabs up at the screen, at the top of the screen? Well, besides fading, we also completely clear those away with that giant circular animation. So we can use reveals to kind of transition our app into different states that we need to transition them to, right? You can use a huge reveal to wipe away the screen, wipe away whatever the user thought was there before, and your user won't even notice it, right? Because most people aren't going to notice the fact that the tabs aren't there anymore. They're just going to notice the giant Instagram logo that's moving around. All right. Next thing, small animations can help a little bit with transitioning your UI. So we have that little animation at the top of the screen, that little arrow animation. How many of you guys noticed that was playing this whole time? Like every single time you play, yeah, one guy. Just for the record, for everybody, one guy noticed it. Yeah, that animation is playing up at the top, but it's so subtle and it's so small that everything else going on the screen completely obliterates it, right? But at the end of the day, we have a back button there. We used to have a menu button, hamburger menu button, right? But now we have a back button. Hey, that's a lot more useful now for this screen because we don't need a menu button on there. We need a we need a back button. We can have hamburgers later. Right, small animations are obscured by big ones. Cool. So let's make this stuff easy. If you learn nothing from this talk, if you go home, forget everything, the one thing that I want you to remember from this talk is this one line of code right here. Animate layout changes equals true. This code is magic as far as I'm concerned. Google has literally taken 99% of the animation work and done it for you with this one line. What does this one line look like? That. That entire animation that's playing right now is done by one line. Well, one line and then setting stuff to be visible and invisible, right? So whenever anything changes inside of your app, when everything changes inside of your layouts, if you have animate layout changes equals true on, your entire app will animate on its own. That transition will happen. The layout will figure out what to move around, what to do, and how to move it in order for everything to fit on the screen. In the case of linear animation or linear layout, this actually works phenomenally well. Use this everywhere. If you just need an animation that plays, slap that line in there, boom, you're done. Now, what if you want to do something a little bit more complicated? Well, you can start doing some manual stuff. So let's talk a little bit about fading. You can animate the object alpha, and this is actually really easy. right? You just take the view, dot animate, alpha. If it's visible, then you want to, if it's visible, you want to set it to 1. And then if it's invisible, you want to set it to 0. Oh, and don't forget the interpolator, because you want this to still be natural. Even though we're animating colors here, we can still animate them naturally. Linear fades still look worse than interpolated fades. So, how does this look? Right? Here's a button, fade, in and out, right? Again, one line of code. Color changing. Let's say you wanted to change colors in your app, right? Let's say a button needs to go from, say, gray to blue. Say, for example, if you're enabling that button. Well, turns out we have this great thing called Object Animator. And we can call objectanimator.ofRGB. We give it a, We give it a bitmap, or in our case, a drawable. And we tell it what property to animate. In this case, we're animating the tint. And then we give it a background color, or our current color, the fade color, set the interpolator, and then we hit start, and that's it. There is one caveat to this. This is API 21, but that's not a big deal. You can do the exact same thing in API 16 and above. All you have to do is instead of passing in, instead of saying of ARGB, you just got to give it a new ARGB evaluator. So that's just, API 21 just has some syntactic sugar for that. But yeah, otherwise, oh, also, perf matters. Don't use set background color. Use tint if you're actually trying to set the background color with this. Tint animates on the GPU, so that's a GPU animation. Set background color is going to reset and invalidate your drawable. So that's going to be a lot slower than just setting the tint. And if you're animating, that matters. You want your animations to play at 60 FPS. So here's what that looks like, right? Have that button, we click it, changes color, everything goes back to normal. Great. Animated vector drawables. All right, bear with me here. These are complicated, but they look fantastic. So, also, they're API 21. You guys can go bug Colt and Chet and ask them when they're finally going to drop this into the Sport library. How do you do an animated vector drawable? First thing that you have to do is you have to declare a vector drawable. You give it your height, your width, same way that you would any vector drawable. But then you also have to define your viewport width and your viewport height. That's actually going to depend on the data that you're going to pass into this vector drawable. So in our case, this vector is going to have a path. And that path is just going to have it's going to have its name, it's going to have its fill color, and it's going to have its path data. In this case, it's string/circle. What is string/circle? String/circle is this giant SVG file. Well, in our case, it's not actually very big, but you can get these pretty large. So in our case, it's just an SVG file. So yep, there it is. There's that circle. And again, the viewport width depends on that string. So you got to ask your designers, if you have any, what the viewport height is and what the basis of all the numbers are, because it's all relative. So then we define the animated vector, right? We got our vector drawable. We can define it as an animation. We tell the Android which drawable to use. Well, you use my vector. We tell it what the path it's animating is called. Well, in this case, it's compression. And then we tell it the actual animation, which is path morph. What is path morph? Path morph is here, right? So this is just a standard animation set. We give an object animator. We pass in the value from and to. So in our case, the to value is string/compressed. And then in this specific example, we actually go backwards after that. So you pass in the duration, and what this will actually do is it'll play those two animators sequentially. And that's because we set the order to be sequential. And then we also set the interpolator. In this case, it's a decelerate interpolator. But cool. So, right, that goes to that. What do animated drawables, vector drawables look like? Well, remember that animation that we had earlier with the back button? That is actually an animated vector drawable, right? So they have 3 lines there, and in one case they have 3 lines in a certain formation, and then they have another vector drawable with the 3 lines in a different formation, and that formation is a back arrow, and then all they do is they interpolate between the two. Google handles all of that for you, all the complicated SVG transformation logic. That's all done for you. You don't have to worry about it. You just create your animated vector drawable. And then the example that I actually rolled, well, that's what that looks like. It's just a circle it kind of gets squeezed together, or rather it's stretched out, and then it goes back to where it was. So, all right. So we've talked a lot about motion. We've talked a lot about animations. Let's put everything that we've kind of learned together. So we've got our natural movement, right? Accelerators, decelerators, interpolators. And then we figured out how to use that guide to guide our users. Well, if we combine those two together, what you actually end up with is fluid motion. So what is actually fluid motion? Well, fluid motion is when elements appear from other elements, and then they disappear into other elements, right? So things don't just spawn onto the screen willy-nilly, right? That's why we're animating these things. The motion is natural, and the motion is subtle, right? So when things spawn elements, we might want the user to notice that. When they despawn, the user probably doesn't care. We're going to be subtle about that. We're going to go ahead and we're going to combine everything that we've kind of learned into this one giant heap in order to create the animation that we need in order to guide our user's focus in a fluid manner. So here's an example from my app, right? Retell Me Not. So we have this navigation toolbar, this home row, and in some parts of the app, we don't actually always need this, right? So how do we get rid of this home row without kind of throwing the user off, right? Because this is like our core central navigation feature, and we want to hide it in some places, right? How do we do that? Well, we do that like this. We fade away the background, and the colors end up on white, and then we just swipe away the colors. Turns out, people don't notice that animation. Whenever we need to play this animation, we need to play it because we're transitioning to a screen that doesn't need that home row navigation. Well, because we're being subtle about this, because it's fast, and because it's fluid, people don't actually notice that this animation plays and that this entire row is gone. So it actually ends up being really awesome, and like we can transition from just the toolbar to the toolbar with the secondary navigation. But we can make this better. Quite frankly, we'd like to have that animation play, and then we'd like to be able to tell the user when the animation is back, right? When those buttons come back, we don't want it to be that subtle. That's not necessarily the right way to go. The way that we can do that, or sorry, actually, I forgot to mention something. Or rather, I talked about it already. Right. The reason that we want to do this, we established the hierarchy between elements. Clearly, that toolbar right there is much more important than the secondary navigation in this case, right? So we established that that toolbar is on top, it's more important, and is always going to be there. The secondary navigation slides in and out depending on whether or not we need it. So clearly it's not as important, right? Tabs are secondary. But then we also build and change scenes seamlessly, right? So we hide elements that we don't need at the moment, right? Unobtrusively. Great. So now then, going back to what we were talking about. Let's say that we wanted to have the user pay a little bit more attention to the actual animation when it comes back in. How can we do that? Well, the way that we do that is by blending colors, right? Again, this is one of the fast pathways in your brain. This is going to be really fast for users to notice. Users are going to notice this, right? So let's say we come in and we have this toolbar and we want to bring back those navigation buttons, right? How can we do that in a much more seamless way? There we go. We can blend the colors together, right? So we're using that circular reveal to kind of come from that top level toolbar, and then we're going to animate in, and we're going to animate in all those tabs. And this tells the user, again, those tabs are back, first of all. It makes them notice that. And the second thing is it tells the user that those tabs are related to that navigation bar, right? So even if we have other stuff on the screen that's going to be purple, the user is still going to notice those toolbar come back in. Cool. Right, brain perf. Group stuff by colors. All right, so we kind of had this weird animation in the beginning of our talk. And right, so this thing. And it's kind of interesting, right? So what is this actually doing? Well, this is blending shapes together, right? So outside of blending colors, which is one of the fast pathways in your brain, you can also blend shapes, another fast pathway in your brain. Turns out your brain actually does this really fast, and it kind of understands this. But this is kind of a weird example. I don't know if you guys remember, but this was one of the examples that I used to define what material is, right? But what material actually behaves like that, right? Like plastic? Not really. Well, It actually turns out that this material behaves similar to what you'd find in a lava lamp, right? That is to say, something gooey. So with that, if we take that gooiness, we can literally create fluid motion, right? So don't just have fluid motion in your app, be fluid motion. Have your views animate as if they were a fluid, right? Make your views gooey. So what is gooey? What does that even mean? Well, you simulate your views as if they were a high viscosity fluid, right? So something that doesn't necessarily flow like water, maybe something more like molasses. Your views look solid when they're stationary, so your views seem as if they were actual buttons or whatever the user needs for that specific case, but they move as if they were liquid, so that they can transform into each other, they can move, they can flow through your app. And before we kind of go on, I want to show you guys this animation by Jakub Bantalik, and I apologize if I pronounced that wrong. But this animation kind of, he posted this on his Twitter, and this animation kind of exemplifies everything that I'm talking about in this talk, right? This is kind of the inspiration for this entire talk and sort of everything that I've been doing for the past month. So I just want you to watch this. Right? Everything flows seamlessly from one scene to the next. More importantly, everything here is providing the user with the context of what they're actually doing within the scene. Buttons transform, you understand what you're doing, right? That blue button transformed into a selector. That selector transforms into an OK button. You know exactly what you're doing on the screen, you know exactly the order of operations, you know exactly what's happening because all of these views are morphing from one to another. It sequentially follows that views that morph from one to another relate to each other. So, let's talk a little bit more about Goop. Goop easily changes shape, which means that you can take something like a square button, animate it into a circle, and it changes that shape, and it goes smoothly. And it's natural, right? If your views behave as if they were gooey, it's a natural animation. Views also can easily create other elements from each other, right? So as you're moving along, if you need to spawn more views, you can spawn more views from one another, and it's naturally understood by the user that those views relate to each other, right? You wouldn't put 3 separate buttons on the screen that animate in that format and then not have them relate to each other. They should all be meaningful, right? So if you have, for example, 3 menu options, you animate them from one menu button, and you get 3 different buttons that all relate to each other, and the user kind of intuitively knows that those things relate to each other because, again, that happens faster in your brain than if they were to scan each and every single one of those buttons and decide whether or not they relate to each other. Right? So relate elements to one another using this sort of GUI animation. So how do you actually do this in Android, right? This is not a trivial task. We're getting into sort of this really interesting part of Android that hasn't been done for you by Google. Everything that I've talked about to this point has already been done for you. Well, we can kind of categorize this Goop into several different situations. And the first one is simple simulations, right? So something that not too hard to kind of fake. And the way that you can do this is with vector drawables and canvas animations. And we'll talk a little bit more about canvas animations in a second. If you have something a little bit more medium complexity, right, then you might want to have an animation list, right? So if you have views that kind of transition between each other, or if that animation is reversible, so you can play it forwards and backwards, you can use an animation list to keep that, to animate that. But that's a little bit more costly for you because you need a designer for that, but we'll talk about that later. And then we have our hypercomplex, right? Stuff that just like, we don't know what, like, we can't do this in any other way. And for that, we actually need true fluid simulation. So let's talk about the simple stuff first. Right? So if we have a static animation that's always going to play, and it's always going to be the same animation, then we can just use a vector drawable, right? We define our Goop in sort of a vector. We can animate between those vectors in the same way that we had before, and then we can continue onwards. If we want something more dynamic, though, we're going to have to use canvas animations. So, good job, Magic Move. Because of course I meant the animations from the other one. Okay, so canvas animations are when you actually override your views, override your drawables, and you create your own paths and you animate your own paths. So this is actually like making and drawing views and invalidating them. This isn't as performant, but it still works on high-end phones. But then again, we're not exactly trying to match this stuff to really low-end phones. Like this is some hardcore animations here, so it's not going to run on a low-end phone, right? So we have this canvas, and we drew this path. This is what this path looks like. It's a simple triangle, right? But if we wanted to make that triangle look and behave a little bit more gooey, we can add a corner radius. And that's what this corner radius kind of looks like. So here we just kind of iterate through all these values, and I show you what the corner radius kind of looks like when you apply it, right? So at some point in time, the corner radius just goes way overboard and it doesn't do anything anymore. But at that point, we can actually start to use it, and it kind of starts looking a little bit gooey, right? So we can kind of use these canvas animations to animate our views, and applying corner radius, we can get a pretty reasonable simulation of what a GUI should look like. If you were to start animating your path, that is to say, take that path, draw it to the screen, and then start changing values every single frame, well, you can animate this really cool sort of GUI-like effect. Again, you want to use interpolators in this because GUI does behave in a nonlinear fashion. We can also use animation sets, right? So for our views that are a little bit more complicated and we can't really do that in a simple canvas animation, we can start using animation sets. So this is a little bit more costly because you have to render your animation first, right? This is pre-rendered animations. You render it in After Effects. You take your frames from that animation, and for the record, about 15 frames is 250 milliseconds, which is what I usually use for my animations. The longer your animation, the more frames you're going to have. But hopefully your animation is reversible, so you can reuse these frames in reverse. We add all of these frames to our animation list, right? And we set the duration to be 16 milliseconds per frame. And then we just apply it to our GUI, or rather we apply it to our view, and we can draw these animations to the screen. I don't actually have an example for this because, quite frankly, in a talk like this, that would just look like a GIF, right? That would look like any other animation because it's just your straight up, what's it called? Movie. Like that's how movies work, right? All right, so what if we want to get kind of complicated with this, right? What if we wanted to actually simulate this stuff on the screen as an actual, actual fluid simulation? So usually fluid simulation is extremely expensive, right? But even if we could simulate it, right, how do we apply that to our drawable? Well, we do that using what I call bitmap mesh, right? So Android has this great feature called Draw Bitmap Mesh, right? This is available from API 1. So this was here from the start. And the way that it works is you take your mesh, right, in the same way that you would have an OpenGL mesh, a square grid, and you can apply that mesh to a bitmap. And what Android will actually do is it'll transform your bitmap depending on that mesh. So if you take your mesh and you stretch one corner of the mesh all the way out, your bitmap will stretch in the same way. So we can use this to our advantage, right? What if we could use a mesh and make it behave like a GUI? Well, maybe we can, right? So this is exactly what I'm talking about. We have this mesh, we made it simulate GUI, and we applied it to our bitmap. So up on the top screen, this is what it looks like without the mesh, and underneath I show you what the mesh actually looks like. So what Android is actually doing is it's deforming that circle bitmap, which in this case is actually just a circle drawable, and it's deforming it in the way that that mesh indicates, right? So turns out that's actually pretty simple. And if we take an optimized physics simulation that kind of is optimized for this rebounding animation and this deforming, we can kind of simulate this stuff, right? So we just render a drawable to a bitmap, right? So we can take any view, any button, anything that we actually want to do, render it to a bitmap, deform the mesh that we draw underneath that bitmap. Android pipes all of that down. By the way, that bitmap mesh is really, really fast. That goes straight from your canvas code straight into OpenGL, because what Android does under the hood is it just creates that mesh as an actual mesh and then draws the bitmap over it as a texture in the same way that a 3D game would. That's really, really fast. And like I said, this is available from API 1, so this can run on something like a Nexus 1 or a T-Mobile G1 or whatever came before that, right? And then we can render that bitmap to a canvas. And then we can actually draw that canvas as our view underneath it. So that's where this comes in, GUI bits. So I've started working on something like this. In fact, the animation that you saw up on the screen was actually rendered by this library. And demo app is coming soon, probably sometime by the end of the year. And I would like to stress that this is an early experimental proof of concept stage library. This is not ready for prime time. Don't try to use this yet. Trust me, I'll tell you when it's good. It'll be V1. There's no version yet. So you guys can kind of download this and you can check it out and play with it a little bit, but it does work and it works really well. The fluid simulation part of this is actually already finished. At this point in time, it's just mesh deformation and bitmap deformation, right? So at this point, all I'm really doing is just trying to get all of the different behaviors that you would expect from a piece of goo to draw into this mesh, and then apply that mesh to your bitmaps, and then move that mesh around in the way that you would expect goop. So I expect to be able to rip apart two pieces of goop and have two separate pieces of goop. So, I guess that's twice in there. All right, cool. So this is like the bleeding edge of design, right? This isn't something that you guys have probably heard of because it's not something that's been seriously propagated throughout the design space. But I see this as kind of moving forward with the natural material design. If you want to follow this, this space in general, there's a lot of designs already up there. Not a lot of implementations, although some designers have gone out and made a couple of implementations. There's some really good ones. You can check them out. Material Up, for those of you who don't know, is this fantastic material animation like repository where a bunch of designers just drop their material animations in there, right? And you can look at them and go like, wow, that's really cool. Let me go implement it. Materialup.com, it's very simple. You can type in GUI into the search box, and you'll actually get a lot of animations. You can also follow me on Twitter, shameless self-promotion, because I'll be tweeting about this quite a bit more moving forward throughout the year as the animation library moves forward. I see a couple people taking photos. So I expect 1, 2, 3 more followers. Yes. Up, 4. And that's almost my talk. But before I go, I want to show you guys this. I don't know if you guys know Luke, but Luke's really popular in the Android space and the mobile space. But this is kind of my first exposure to GUI. It was thanks to Luke. And I just really like that line on the second tweet, GUI is the new flat. So GUI is the new flat, guys. Get cracking.